SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Systems Technology Part 2 Module 20. We are going to learn how to plot or how to record the data so that we can plot it in the control chart. So, I think I had discussed this earlier in quite a bit of details, the milling example, where we are talking about this terminal block slot, and we have recorded them as subgroups, various subgroups, and each subgroup has about 5 observations, as you can see, A to E. And the units of measurements are recorded as 0.0001 inches over this 0.8000. So, this is something which we are doing just to prevent the redundancy of calculations. I had shown you earlier that in such cases you have to do a transformation. You are basically doing the transformation by deducting 0.8000 from the 0.8750 mean value, and then multiplying this with or multiplying this with 10 to the power of 4, so that you can have real values which are fit for calculations, etc. And then you can do the transformation back again once you have been able to generate the information on the mean and the standard deviation through this statistical method. So, you can see here there are about close to 16 subgroups which are available, and they have been recorded at different points of time. In fact, this is the data for close to about you can say, let us say it started from 3/7, so basically 7th of March all the way to about 3rd of April. So, it is near about a 1 month data that we are talking about, and there are not all days on which the data has been taken. Basically it has been taken on 7th of March 3 times or 3 subgroups, again 8th of March 3 times or 3 subgroups, again 9th of March again 3 times 3 subgroups, similarly 10th of March, and then it has been taken on the 2nd of April again 2 times, and 3rd of April 2 times, to probably there was some degree of control of the process which was executed in this process, and they found out that on 10th of March probably the process was back to control. So, they again checked it once in a while for again 2 subsequent days in the month of April. So, having said that, if you look at the various observations which have been made here, this represents 0.8772, and because of the transformation done here, it is shown as 772, 804, 779, 719, 777. So, this is how you have calculated. So, basically it means 0.8774 sorry 2, 0.8804, 0.8779, 0.8719, 0.8777 is over and above 0.8000 and multiplied by 10 to the power of 4, so that you can have this as a factor coming out. So, obviously the total is calculated here of all these values, so that you can calculate the average, and the range basically is the maximum observation minus the minimum observation. So, in this particular case the maximum observation is 804 and the minimum value is 719. So, that brings about close to 85 as the range. So, that is how you have calculated the x bar and the r here for all these different distributions. So, you have 750 and 54 as subgroup 2, 751 and 51 as subgroup 3, so on and so forth, up to 777 and 27 as subgroup 16, so on and so forth. So, therefore, you record all these different 16 observations on a vertical table in terms of the x bar and the r charts, and you calculate the means of mean, so basically x double bar. So, the mean of means, so the total here happens to be 12,129. So, you divide that by the number of observations or subgroups, that is 16, and record this as 758. So, that is the mean of means, and the average range which comes out to be 621 by 16, which is about 39 in this particular case. So, obviously because we are talking about a subgroup size of 5, so in the x bar chart this data is available in the tabular manner, which I am going to share later, but then A2 basically, which is the coefficient of the deviation of the range with respect to the mean of means, is actually a function of the subgroup. So, the A2 for a subgroup size of 5, for a subgroup size of 5 is recorded as 0.58, and so therefore, you can have the two limits defined as x double bar plus A2 r bar, okay, which is actually in this case 758 plus 0.58 times of 39, which is the r bar, okay. So, this comes out to be 781, and the lower limit of the x chart happens to be x minus A2 r bar, which is 758 minus of 0.58 times of 39, which is actually equal to 735. So, that is how you basically find out the upper and the lower control limits in this particular case, okay. So, that is the modalities part. Now, due to a small number of available inspection personnel, it has been decided here that for each chart the sample would be inspected approximately 5% of the total production of the parts in question. So, this number, which is actually coming, that is subgroup of 5 and x number of times it is being repeated during a day, that is essentially the 5% production limit, that is 5% of the total production limit that is used for determination. So, it has been also decided that all measurements would be made at a place of production, and it was decided that a part be measured every 20 parts produced, because it is 5%. So, obviously out of 100, 5 out of 100 and 1 in every 20 parts, and so therefore, the subgroup size was sort of fixed looking at this 20 parts, 1 in 20 parts as sort of 5, So, figure on the left shows all the observations here. So, the method to inspect was really to secure the data for each chart, was to measure two portions of the slot width using micrometer screw gauge, average these measurements. So, these are actually average measurements. So, that is how the modality was, and this is how the control chart is. So, having said that, we from this data borrowed from this table, control table, we start plotting the chart. So, the limits 0.8781, which is a transformation into the upper limit, which was obtained here 781. So, basically it is over and above 0.8000, and it is multiplied by 0.0001 times of 781. This is the transformation. So, 0.8781. So, this is the upper limit, and similarly 0.8735 is the lower limit. So, that is how you have plotted both the lines here, 0.8781 and 0.8735, and obviously the central line is corresponding to the mean of means, that is x double bar 0.8758. So, the actual measurements of the first 16 subgroups are shown in this particular table. The numbers of subgroups correspond to a production order of for 1600 on these terminal blocks. So, therefore, the subgroups correspond to 16 times 5, about 80 parts, which is about 5% of the 1600. So, that is exactly compliant with the norms of recording 5% of the total production limit as decided in the control chart scheme. And we can see here the plot of the x bar corresponding to the different values recorded. For example, in this particular case, the x bar comes out to be 0.8770. So, you can see this point to be 0.8770 as the first subgroup. It is quite away from 0.8758, as you can see. This is again the second subgroup, which corresponds to the term again, if you look at 0.8750. So, it is below the 0.58 subgroup. So, it is below here. So, this is the second point, then the third point correspondingly, the fourth point, fifth point, sixth point, seventh point, so on and so forth. So, basically what you are trying to do is to plot these 16 subgroups, as you can see as recorded here as x bar, and so that is how you are recording all these 16 subgroups. And so therefore, it is very obvious to record all this in a control chart domain as UCL and LCL, and similarly there are certain aspects which can be noticed. So at the time of the 12th subgroup, so this is about this particular subgroup, before the completion of the production order and before the calculation of the central line for the control limits, the quality control inspector noticed that the machine operator was occasionally checking performance on a terminal block that had just come off the machine and was still hot. So after the 12th subgroup, as you can see, suddenly there is a change in the overall level of the measurements because of this additional factor of the cooling which has been introduced into the measurement system. Okay, so it is basically very much visible, whatever decision making we are taking to control or modify the way that inspection is carried out, or even the control chart is plotted, it is being recorded very judiciously in the control chart, and it comes out because of the process, it is very foolproof. So in a nutshell, we had about 16 subgroups, and the subgroup size was determined as 5, for which we calculated the A2 and D4 factors for the X double bar and the R charts. So now we will plot the R bar chart. So obviously the R bar or the range bar was determined from this particular value here as 621 divided by 16, that is 39. So if I just do the transformation on 39, that is 0.0001 times of 39, whatever is the transformation allowed, the range chart comes out to be mean or centered about 0.0039, which is being illustrated here. And if we had a subgroup size of 5, the lower level of the range chart is really eliminated because it is above the subgroup size 5 that you consider the lower range, but the upper range can be represented by, in this particular case, the D4 coefficient times of R bar, and D4 in this particular case comes out to be about 2.11 from the table that is being considered. So 2.11 times of 0.0039, that is close to 0.0082, and that is the upper control limit for the range chart. So essentially these crosses now are looking at the different subgroup ranges which have come out, and if I may recall that these were the ranges which were plotted here as 0.0085, 0.0054, 0.0051, 0.0036, so on and so forth. So those are being plotted as subgroup 1, subgroup 2, subgroup 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay. So that is how you are plotting the different 16 subgroups. What is important here is the subgroup 1 is above the upper control limit on the R chart, that is what you can see right away. Upper control limit is 0.0082, and the data that was recorded was 0.0085, so it is well above the upper control limit of the range chart. Subgroup 10, for example, is below the lower control limit on the X chart. So this right here, the 10th figure, is actually below the LCL on the X chart. Moreover, the last 10 of the 6 points fall below the central line. Okay. So if you look at the way that this chart has been plotted, the range chart, for example, if you look at let us say starting from 16, so 16th, 15th, 14th, 13th, 12th, 11th, 10th, 9th, up till actually 9th, all these different values, at least 6 values, they are falling below the R bar or the mean of the R chart and below the center line. So in a way the range is not showing control adequately, whereas in the process or in the subgroup 10 the observation really goes beyond the LCL, and so it is amenable to rejection at that particular stage. So the control chart gives you some estimation or some data regarding the interpretation regarding how the data etc. is plotted. So, having said that, now I would just like to close on this module in the interest of time, but in the next module we will discuss how because of some changes there would be a shift in the way that we are plotting the control chart and consequently what would happen in terms of the process control during that illustration. So, as of now thank you very much, we close this module, thank you.